Application of principle of parallel and perpendicular axis on disk. See, now we will find moment of inertia of thin disk about axis passing through center and perpendicular to the plane. Okay, we'll take different axes here, but first of all, we'll find the moment of inertia about an axis which passes through center of the disk and the axis is perpendicular to the plane of the disk. Okay, so for this, consider a disk, and this is the axis about which we are going to find the moment of inertia. And this axis, you can see it is both perpendicular and passing through the center. And the center of mass of the disk also lies at the center of the disk. Okay, geometrical center of the disk. And we can assume, see here, as we always, take small elements, right? In case of uniform rod, we had taken small element dx of length dx and of mass dm. In case of ring, again we had taken a small element dx on the circumference of the ring, right? Here also we can assume disk to be made up of a large number of concentric rings. Concentric means rings are the rings which have their common center. Concentric, they have the same center, but radii are different. Okay, so we have rings of different radius here. So we'll assume one such ring on the disk, and this ring is at distance x, okay, from the center. Or we can say radius of the ring is x, and it is very small, very thin ring, okay, of very small, thickness. Thickness of the ring is dx. Okay, thickness of the ring is dx, and length of radius of the ring is x. So we can find mass per unit area, because you can see, for if we have something like rod or ring, in that case we find mass per unit length of the ring. ठीक है, तो इसमें हम क्या फाइंड करेंगे, एरिया फाइंड करेंगे. तो मास पर यूनिट एरिया इज गिवन बाय m upon pi r square. ठीक है, अगेन वी आर अज्यूमिंग दैट देयर इज यूनिफॉर्म मास डिस्ट्रीब्यूशन. तो जितना भी मास है, अगर आप जितनी भी रिंग्स कंसिडर कर रहे हो वहां पे, तो वहां पे यूनिफॉर्मली मास डिस्ट्रीब्यूटेड है. As we have found out mass per unit area, now we will find area of the ring that we have just assumed here, जो yellow color की है, और उस ring का भी mass हम find करेंगे. ठीक है, so area of the ring क्या होगा? Circumference of the ring is 2 pi x. 2 pi x is the circumference of the ring, and you can see that the ring is thick. ठीक है, and thickness of the ring is given, it is dx. So if we multiply thickness with the circumference of the ring, then we get area of the ring. Okay, so area of the ring is 2 pi x into dx. ठीक है, now we have got the area of the ring, so we'll find mass of the ring. And how will we find mass of the ring? Mass of the ring is mass per unit area of the disk multiplied by given area. So mass per unit area is m upon pi r square, because we are assuming uniform mass distribution. And if we'll multiply area of the ring with mass per unit area, then we'll get mass of the ring. Okay, on solving this, you can cancel this pi here, and you'll get 2m by r square x dx. So this is the small mass of the ring. Okay, now for this ring, we can find moment of inertia about the axis which is passing through center of the ring. Okay, the moment of inertia of the ring about an axis which passes through center of the ring is mr square, and here we're taking the small mass of the ring dm, and into r square. Radius of the ring is x square. Okay, radius of the ring is x square and mass of the ring is dm. So we can find moment of inertia about the axis which passes through center of the ring. नहीं आया समझ? Is this clear?
Yes, ma'am.
Yes, ma'am.
Okay, so it's 2m by r square x dx. Okay, now we will integrate it to get total. First, we'll find moment of inertia because of this ring. It's di. It is equal to dm into x square. Because for ring, we write mr square. Okay, for a ring, moment of inertia about the same axis is mr square. So here in place of m, we have dm, and in place of r, we have x. X is the radius of the ring. So up dm के place पे we can put this 2m by r square x dx. ठीक है? Okay, so this is the moment of inertia about an axis which passes through center and perpendicular to the plane of the ring that we have just, considered. Up total mass of the whole disk, because we have found out the moment of inertia about just one ring. So we have a number of rings in the disk. So if we want to find moment of inertia of the whole disk about the same axis which passes through the center and perpendicular to the plane of the disk, then we need to integrate all the moment of inertias because of rings that, that constitute the disk, that form the disk. Okay, for this we need to integrate this small moment of inertia to get total moment of inertia. Okay, now this di is this 2m by r square. This is, constant. So we can write this outside the integration. And in the integration, we have just x cube dx left. We are integrating from 0 to r. Why are we integrating from 0 to r? Because we have these rings from, as we move from the center of the disk to the outer layer. Just, जो edges जो है उसकी डिस्क की, वहां तक जब हम जाएंगे तब हमारे पास बहुत सारी रिंग्स हैं. That's why we are integrating from 0 to r. ठीक है, क्योंकि 0 to r इंटीग्रेट कर रहे हैं क्योंकि हम रिंग्स कंसिडर कर रहे हैं. किसी स्पेसिफिक रेडियस पे आपने एक रिंग लिया, हो सकता है किसी और रेडियस पे हम दूसरी रिंग भी ले सकते हैं. थोड़ा सा कम रेडियस करोगे अंदर वाली रिंग आ जाएगी, थोड़ा सा बड़ा करोगे बाहर वाली रिंग आ जाएगी. राइट, सो विल इंटीग्रेट फ्रॉम 0 to r. ठीक है, तो ये आपका ऑन सॉल्विंग यू विल गेट दिस. This is the final answer, mr square by 2. We have questions based on this. Moment of inertia of disk about an axis passing through center and perpendicular to its plane is. Correct answer is
Option B.
option B, r square by 2. Next question, consider the disk. Find the moment of inertia about any diameter. See, we know the moment of inertia of the disk. Moment of inertia about an axis which passes through the center and perpendicular to the plane of the disk, right? And it is mr square by 2. What if I want to find moment of inertia about any diameter? Then for this, in this, as we have done for the ring, in the same way we can do for the disk. Okay, which theorem we are going to apply here?
Perpendicular axis.
Very nice. Theorem of perpendicular axis. So it's ix plus iy gives iz, and iz is mr square by 2. And because along the diameter, if we are taking the perpendicular diameters, which are one along x-axis, other along y-axis. So both the moment of inertia are equal. Both ix and iy are equal, right? है ना? So we can write iz as ix plus iy. And due to the symmetry of figure, both the moment of inertia are equal. So we can write either 2ix or 2iy. It's a choice. So in this way, we can write ix as iz by 2, or this is answer is mr square by 4. So moment of inertia about the diameter of the disk is mr square by 4. Okay. Now we have to find moment of inertia about a tangent which is perpendicular to the lamina. Which theorem are we going to apply here?
Parallel axis theorem.
Very nice. So moment of inertia about an axis which passes through the center of the ring and perpendicular to the plane of center of the disk and perpendicular to the plane of the disk is mr square by 2. Okay, and this is the radius. M is the mass of the disk. So we have to find moment of inertia about this axis. We can write this AB. So moment of inertia about this axis. This is the tangent. It touches the disk at just one point and it is perpendicular to the plane of the disk. So IAB is IZ plus mass and square of the distance. This is how we write. IZ is mr square by 2 plus mr square. And your answer is 3mr square by 2. Now this time we have to find the moment of inertia about a tangent which is parallel to the lamina. So what is the moment of inertia of the disk about an axis which is, along the diameter, about its diameter? What is the moment of inertia about the diameter of the disk? It's mr square by 4. right? It's mr square by 4, and we again will apply parallel axis theorem here. So distance between these two axes is r, radius of the ring, and let this be AB. So we can write IAB as, suppose this is passing through the center of mass of the, we can write C for this, okay? IC. So this is IC plus mass of the disk and square of the distance between the two axes. So it is mr square by 4. We have written ID already, no? Just write ID. IAB is equal to ID plus mass of the disk and square of the distance between the two axes. ID is mr square by 4 plus mr square. On solving, you will get 5 mr square by 4. So this is the first question that we have. Two copper circular discs are of the same thickness, and diameter of A is twice as that of B. The moment of inertia of A as compared to that of B is twice, 4 times, 8 times, or 16 times. See, we have copper circular discs, means they are of the same material and they have the same thickness. Diameters are different and we have to compare their moment of inertias. See, for this, we need to understand that first, for the disk, for any disk, moment of inertia is mr square by 2. Okay, so for disk A, we can write moment of inertia as IA. So mass of the disk is MA, radius of the disk is RA. So we can write MA RA square by 2 for the first disk A. For the second disk B, we can write MB RB square by 2. Okay, now on comparing these two, by taking the ratio, by dividing the two expressions, we can get the ratio IA by IB. ठीक है, तो हाफ ऑफ आपका कैंसिल हो जाएगा और आपके पास आ गया MA RA स्क्वायर अपॉन MB RB स्क्वायर. See, mass of disk A. ठीक है, we can write mass of disk A as volume of disk A multiplied by density of disk A. ठीक है, volume of disk A is, this is a disk, right? डिस्क का वॉल्यूम फाइंड करना है तो कैसे फाइंड करेंगे? एरिया ऑफ द डिस्क multiply by its thickness is the volume. See, if we have a disk and this is the thickness of the disk, so area of the disk is pi r square and its thickness is t. So pi r square t is the volume of the disk into rho A. Similarly, we can write mass of disk B. It is volume of the disk B multiplied by density of the disk B. Volume of the disk B is pi RB square T. This is the volume of the disk B and density of the disk B. Now it is given that they are of the same material, copper. So the densities are equal. So rho A is equal to rho B. Okay? And they have the same thickness. Same thickness hai. So we have already taken the same thickness T because they had the same thickness. Okay? Now on dividing these two, MA by MB, we can cancel this rho A, rho B. We can also cancel T. We can also cancel pi. Okay, so we can write IA upon IB as, in place of MA, now we can write, see, now we are getting only this, na, RA square upon RB square. So in place of MA by MB, we can write RA square upon RB square. Okay, and for, we already have this RA by RB, na, so we can write that also. RA square upon RB square. So in this way we have RA upon RB raised to the power 4. Okay. Now diameters are given. Diameter of A is twice as that of B. So diameter of A is twice as that of B. Therefore radius of A is also double. है ना? Diameter double, diameter अगर twice है तो radius भी तो twice होगा. So we can write this as 2 raised to the power 4. If we put this relation here, we'll get 2 raised to the power 4. It is 16. Answer is 16 times. Next, now we have a solid cylinder. And we have a solid cylinder. The way we have found out the moment of inertia for a hollow cylinder, in the same way we can find for solid cylinder. So if I take a slice from this solid cylinder, then what will we get?
Disk.
This time we'll get a disc because it is solid. Because it is solid. We have a solid cylinder. So if we take a thin slice of it, then we'll get a disc. And the axis is passing through the center of the disc and perpendicular to the plane of the disc, no? So what is the moment of inertia about this axis for a disc? About this axis which passes through the center and perpendicular to the plane of the disc?
mr square by 2.
Very nice. It's mr square by 2. So for a disc, it is mr square by 2 and we have a number of discs, right? Joined together. So if the समझ आ रहा है डिस्क का जो मोमेंट ऑफ इनर्शिया है वो ही सेम मोमेंट ऑफ इनर्शिया होगा आपका सॉलिड सिलेंडर का किस एक्सिस के अबाउट एन एक्सिस ऑफ इट्स सिलेंड्रिकल सिमेट्री ठीक है सो मोमेंट ऑफ इनर्शिया ऑफ अ सॉलिड सिलेंडर अब सॉलिड सिलेंडर से बात नहीं बनेगी वी कैन ऑल्सो फाइंड मोमेंट ऑफ इनर्शिया ऑफ सॉलिड सिलेंडर अबाउट एन एक्सिस perpendicular to this like in this way okay but now in this topic we are finding the moment of inertia about its cylindrical symmetry. Cylindrical symmetry is this thing. ये इसकी cylindrical symmetry है और ये axis है जो उसकी cylindrical symmetry के along है. This axis is along the cylindrical symmetry. ठीक है तो about this axis moment of inertia is mr square by 2. Clear?